Right. So we're gonna start the class here. It's been 10 o'clock. So today I will be going over chapter 5, finish up chapter 5 here, the binomial distribution. And then we'll start chapter 6. I do have some announcement for you guys before we start the class. So here's an announcement. The first announcement is your test. Just want to point out is your test is next Wednesday, July 3rd. It does cover chapter 1, 2, 3, 5, and 6. We skipped chapter 4. We are in 5 and going to 6 today. It is from 10 o'clock to noon, so it's a bit longer than our class. Usually our class ends at 11:25. This one is going to extend to 12 o'clock noon. So it's going to be 2 hours long midterm. It will be in CBT 160. So this midterm will be meet in person in CBT 160. So make sure you guys come a little bit early to college because you might need to find where is this place is. If you know where the location is, perfect. If you doesn't know, I recommend you to come at least 5 or 10, 15 minutes early so you know where was it at. We are using computer lab here, so because we are using StatCrunch when you do your test, so make sure you make sure you if you have a laptop, you can use your laptop. Otherwise, you can use the computer provided in the school here. Also, don't forget you're allowed to use one front page of note. Any note will be allowed to use here. So I would highly recommend you to use any notes that you got. Okay, only one front page, not back, front and back. Okay. The next announcement about your test here is that we will be it will have 10 multiple choice questions, and then it has a 4 to 6 open-ended questions. So this is the part. We'll be reviewing next week before you take the test here. Okay. Now, I know July 4th is an holiday, Thursday, and July 3rd, we have midterm. And I know some of you might have plans with family or anywhere for anyone for vacations. So if you cannot take the midterm on next Wednesday, please contact me as soon as you can ASAP. In this case, this is very, very important. Okay. So that is something that I want you guys to know that. Okay. So anyone have any questions with your midterm here? I will send an information, more detailed information today after class. Okay. So you will see an email from me. All right. Anyone have any homework questions? Because there are 3 homework due tonight, 2.3, 3.1, and 3.2. These are the homeworks that is due tonight. Anyone have any questions that is due tonight? Any homework questions? If you do, please talk to me after class because that's my office hours. So please, if you have any questions, talk to me. So today we will continue on the binomial distribution. In the binomial distribution, make sure you guys know that these are the 4 requirements for binomial distribution. Make sure you know that you have a fixed number of trials. In this case, n is given to us in the question. And usually in the question, if you see the word randomly, means that will be the number n that we use. Okay. And we will not just chapter 5 throughout the entire class, starting chapter 5 onwards. If you hear the word randomly select, the word random, the number next to it or nearby it will be what we call as your n, sample size, or sometimes we call it number of trials. Second one, independence. Then we have a 5% cumbersome rule about independence here. So if you do something without replacement, make sure that you will use this 5% rule to figure out your independent here, because if you've done any sampling without replacement, it is treated as a dependent case. Okay. The third one is make sure you have a 2 categories, success or failure. And the fourth requirement is the probability of success remains the same. Okay. Here are your notations here. P stands for probability of success, usually given in the question as percentage. And Q is a probability of failure, where the formula is 1 minus P, which is not given in the question, but you need to know that. I will tell you why. Okay. For the N is a number of trials. X is a specific numbers, and usually the X came from the word after the word probability. So find the probability. And then we have these words that you need to know. The word exactly, which is equal, more than or greater than, we use the greater than or more than symbol. Less than, fewer than, we use the less than symbol. At least or significantly high, we will use a greater than or equals to symbol. At most, significantly low, we use less than or equal to symbol. So these are very important piece here. So this is used when you use your StatCrunch to figure out your probabilities. Okay, so then the probability of getting X success is PX. We are not using formulas. We are using StatCrunch. In the StatCrunch, we use stat calculators binomial. And then we will use that. Again, I will show it to you in today's class how we do this. And then for the binomial distribution, we have the mean and the standard deviation. Now, you can use 5.1, that one you learned on yesterday's class, how do you find the mean and the standard deviation. However, if you have a binomial distribution, then it is, you can use the formula of n times p, or for the population mean, or the population selection of square root of NPQ. So the reason why I say you need to know Q here is because of this case. The binomial for the standard deviation is the square of n times p times q. So q is where you need it on this case. Okay. And then once you know your population mean and the population standard deviation, you can figure out significantly low or significantly high, either using range of rule of thumb or using the probability. Okay. Again, these are very similar to what you did in 5.1. Again, in your test, you can use either one of this. Okay. Now, we will continue with question number 3 today. Okay. So in question number 3, they will ask us that do we have doing what we call as a hybridization experiments where P's are used for offspring. So points, if you do this, they kind of given us that the 0.75 probability of P is having a green pot. So so this assuming that the offspring P's are randomly selected with group of 10. Now, this is quite important here because you need to know which one is which, okay? So, so when I give you the 0.75 probability of the P has a green pot, so it's going to be one of this notation. Either is P, Q, N, or X. Now, you know that Q usually is not given the question, so that will be out of the notation here. So it's either P, N, and X. Now, since this question is given us by the word probability, so this is actually is P. Okay, so probability of success. So so make sure that if a question given us as a percentage or a probability, so this will be your P in this case. So P in this case will be 0.75. Okay, and then assume that the offspring P's are random selected in groups of 10. So again, the word randomly selected is used. So this 10 in this case is what we just did last time here. That will be your N in this case. Okay. So make sure you guys know how to pick up which one is which. Okay. So that's why in the test I need to teach you how to do that. So these are the keywords we are looking for here. So question A in this case is asking us to Find the mean and the standard deviation of the number of peas with green pods that is in the group of 10. Okay. Now, since the question in this case is asking us to find the population mean and the population standard deviation. So in order for us to find that, you have two ways. Either one, you can use the formula because this is a binomial distribution. So the mean in this case is given us by n times p, where in this case is, I will put parentheses, so n times p, n is 0.75 times with p, n is 10, sorry, p is 0.75, you given us in the question. So if you take the calculator and multiply 0.75 by 10, you will get 7.5. So this is actually your mean. And some of you will ask me what is the unit in this case. This is the unit here is number of peas with green pea pods. So we are doing green here. Okay, so this is the unit. Okay, now next is the Q, the standard deviation. In order for you to find the standard deviation is the square root of n times p times q. However, the question here only provides us n and p. It does not provide us q. And what is q stands for again? Q is the probability of failure where the formula is 1 minus p. So what we do in this case is you have to calculate Q first in order for you to figure out. And sometimes you will know what is Q already, where in this case, if your P is 75% are green, Q in this case means what is the percentage that is not green in this case. So you will figure out that something is wrong in my, this is 1 minus P. So you just subtract it from 1. So 1 minus 0.75, that means this is 0.25. So this is how you figure out your Q in this case is you take 1 subtracted from minus from 0.75. Some of you know that what sometimes I call it the complementary rule. So if 75% are green, then how many percent are not green? So 75 opposite will be 25%. So so that would be your Q in this case. That's what we call. So so what we do here, class, is we're gonna use that. So it will be a square root of n, which is 10, times p 0.75 times 0.25. Okay. So this is the standard deviation. So you're gonna use your calculator in this case. So make sure you know where is the square root is. So for this case, it's right over here. But because it's a computer calculator, you have to multiply first, then apply the square root. Usually in your normal calculator, you use the square root first, you press the square, and then you multiply everything in. So 10 times 0.75 times 0.25. So multiply what is inside the parentheses, and then take the square root of it. Okay, so that is a square root symbol here. That will be 1.37. So this is very close to 1.37. Okay, so this is how you find the population mean and the population standard deviation for this question. Now, is that another way for you to do this question? If you forget the formula, the answer is yes. There is another way for you to figure out these formulas, and this is going to be a little bit more difficult. The reason why is because you have to build what we call as a probability distribution. So you can, and then you use that once you do it. So in this case, you will do 0, 1, 2, 3, 4, 5, all the way up till 10. Okay, and the reason why we go all the way up to 10 is because our n is 10, because we got 10 and 10 p's there. Okay, and now you have to figure out probability for each one of this. This is where you're gonna be taking the most time. That's why I do not want to show you this way. So I'm gonna put it right here. So you guys can see it over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Now for the next one, in order for you to figure out the probability, you have to go to do this, go to stat, calculator, and binomial, because we're in the binomial distribution here. Your n is 10 because our sample size 10, our p is 0.75. And you have to use the equal to 0 to figure out the probability of the first one. This is where I say this is very difficult here. So this probability in this case will be 0.00000095. So this probability, I'm going to copy this and I'm going to paste it right over here. Okay, so this is the meaning of that. And then you're going to change it to 1. And you're going to copy this and paste it over here. Yes, this is, so if you want to do the difficult way, this is the difficult way. Copy and paste. So keep on doing this for the rest of the X in this case. So fill in this table here. So copy and paste. And this is what happens if you forget your formula. Okay. The difficult way. Control V. Then we do 5. Yes, this takes the most time. But it's still doable. It's not that tough here. 6. Copy and paste. It's very tedious. Oopsie. Yeah, it's a lot of work. Oops. Not 10. Let me finish up this paste so you will see. Please, class, if you want to do it this way, make sure that you do it correctly, since you're spending quite a bit of time here to. Okay. All right. So once we finish out entering all this data from 0 to 10 for what we call as a probability distribution. So this is what you guys learned in 5.1. Okay. So this is all filled out, like what I just showed to you. You go to stats, go to calculators, and custom. Remember we did in 5.1. Stat, calculator, and custom. The variable values in var1, weights in var2. Okay. And you hit compute. You find out that the mean here is exactly the same as 7.5. And the standard deviation, the population standard deviation here is 1.37, which is exactly the same as the one that we just did just now. Okay, so that's the reason why that this is your second way. So that's why this is what I call the second way here, or use 5.1. You see the 5.1? This is the 5.1 that we use, which is going to be a bit more difficult than using the formula. Okay, so you guys know that the formula is pretty straightforward type here. So that's the reason why that I will highly recommend you to use the formula instead of using the 5.1 way, which is, you can do it this way, which is not. Don't forget, this is for 10. Imagine you got 100. So if your n is 100, you're gonna do this 100 times. Okay. So so that's the reason why that I do not highly suggest you guys to do it. But if you want to, you can. Okay. Question B. In order for you to question B, you have to use a range of rule of thumb. So range of rule of thumb means you have to use the mean minus 2 times the standard deviation and mean plus 2 times. So you have to take the mean. Now, where is the mean and where's the standard deviation? Is right here. So you will use the mean and standard deviation found in A or found in here, the mean and standard deviation that you found early on in the StatCrunch here. So you will take 7.5 minus 2 times 1.37. So I'm going to use, again, calculators to do this work. Clear the follow up. So 2.7, 7.5 minus 2 times 1.37 that will give us 4.76. So this will give me 4.76. And then we do the same thing on the other side, 7.5 plus 2 times 1.37. So we're going to figure out what is the higher part of this. So calculator again, 7.5 plus 2 times 1.37. So this came out to be 10.24. Okay. And with this, any green peas, if you open up, there are 4.76 green peas or less, is gonna be considered significantly low. And any high 10 point, if you open up 10 more than 10.24 green peas, then is considered significantly high. And if you found right in the middle, that would be no significant in this case. Okay, so again, your units are all green peas here. So this is how you figure out using range of rule of thumb in this case. Okay. And part C, the question is asking for, is having 9 green peas significantly high? So again, there are 2 ways for us to do this question. One way is using ROROT. How do we use ROROT? Is we got the ROROT. If you have the ROROT done like part B, you just figure out where is 9 at. Okay, so this is 4, this is 10. So 9 green peas is somewhere here. Okay, because this is 10.24. So if you think about this on number line, so this is 9 is right in here. And you find out that 9 is right inside this, is right in the middle. So, so in this case, the answer would be no. 9 is not significantly high because it is inside ROROT. Okay. So this is one way to do it. Either you use ROROT, or if you do not want to use ROROT, you can use probability. Okay. So so when you use probability in this case, you want to find what is significantly high. So if you remember, significantly high means we're gonna use the greater than or equal symbol. So in order for us to do that, we have to use what is find the probability of x is greater than or equals to 9. Okay. So you're gonna find what is this probability is. So how do you find a probability? You go back to the binomial calculator. Stats calculator binomial. 10 is your n. P is 0.75. And you need to find what is greater than or equals to 9, which is significantly high in this case. This probability came out to be 0.244. And since this probability is more than 5% or 0.05, so your answer is no. So 9 is not, what happened to? So 9 is not significantly high because 0.244 is greater than 0.05. Okay, so this is how you figure out if you want to use probability. Okay, so again in the test you will do one of this way if they ask you for significantly high or significantly low. Either way is fine as long as you explain. That's why you have to use explanation in this case. Okay. Anyone have any questions on this problem number 3? Question number 3. Right, we're gonna do the last question here. That will be question number 4. So in question number 4, we have a pharmaceutical company receive a large shipments of aspirin tablets and use this acceptance sampling plan. What do you mean by acceptance sampling plan? Means that they will accept this batch of shipments of aspirin tablets if you have this condition. Okay. If you randomly, here's a word, randomly select 40 tablets, and they will only accept this whole batch if only one or none of those does not meet the requirement specification. Means that if you have a whole batch of aspirin came today, you will randomly select 40 aspirin from this batch. And if one of these is bad, or none of those, means all of those is good, then this whole batch we will accept. Okay. If there is 2 out of this 40 randomly selected, if 2 aspirin or more is bad, then this whole batch is gonna be rejected. Okay. So 2 or more, 1 or 0, we accept the whole batch. 2, 3, 4, 5, up to 4 or 40 of that, then the whole shipments has to be rejected. That means you have to return back. Okay. In one of the shipments that is 5,000 aspirin tablets, it has a 3% rate of that defects. That means that the chances of you getting a defect on the aspirin here is 3%. Okay. Now this 5,000 here is redundant because that is your capital N. Okay. So we don't use this. So the question is asking for what is the probability that these shipments will be accepted? And then the second question is, are such shipments being accepted or are they being rejected? Okay. So how do we do this kind of question is first, this is a binomial distribution due to the 4 requirements that we have. We do know what is N in this case because it comes after the word randomly selected. So N in this case will be 40 because that would be not 5,000. Okay. And then we also know the P in this case. Now, since the probability of defects is 3%, so your P in this case is 0.03. Okay. So we are doing the defects one. That means that is no good. Okay. Now you only accept these shipments if your X in this case is 0 and X in this case is 1. Okay. So what does that mean is you only accept this batch if 1 is bad or 0 is bad. Okay, it's written down here. 1 or none is bad. Okay. Now, if you look at this, if 0 and 1, this, if you want to put this in a mathematical form, this is the same thing as probability of X is less than or equals to 1. Okay. So if you do 0, 1 is less than or equals to 1. So in this case, we will use the StatCrunch to do this binomial case, where N in this case is 40. And your probability of defect is 0.03. And you will only accept these shipments if you have 1 or less, or 1 or 0, 1 or less in this case. So this probability in this case of acceptance is 0.6615. Again, I put in 4 decimal place here. So this is how you figure out this case. Now, if you do not want to figure out this case, you can find the 0 one first, but make sure you put the equal sign. So the 0 one will be 0.2957. And then you change it to 1 because you have to do 0 and 1. So that will be 0.3658. So 0.3658. And if you add these 2 numbers out, you should get around 0.6615. So there are 2 ways for you to figure this question, how to do this question. Is either you use less than or equals to 1, which you only do it one shot, and that's your answer. Otherwise, you can do equals to 0 and equals to 1 here, and then add up this probability. Okay. That means that what you're looking for here, class, is 66 point, so what is this means? 66.15% is the acceptance rate. Okay. What does that mean here, class? Is it means that if a shipment comes in with this scenario here, 66% you will only accept this batch or these shipments. So what is the rejection rate in this case? So this is where we're gonna do the second question. Okay. So that means that the rejection rate is 100%, take away 66.15% that we have. So if you take 66.15, 100 minus 66.15, the rejection rate is 33.85%. Okay. So now to answer this question,
Question.
Yep.
Would that number also appear if you went to the binomial calculator and then you did greater than 1?
Yes. Greater than. Yep. So make sure you use greater than. Yep, which is this one. Not greater than or equal to. You're correct.
Could you try it just to see?
Yep, right here.
What if you compute though?
Right there.
Oh, sorry. I'm sorry. I'm looking at something else.
You're fine. So it's the same as that number. Yep. Yep. You're correct. Make sure it's greater than, not greater than or equal to. Otherwise, you get it wrong. Okay. So make sure it's greater than. Yep, you're correct. You can do that way. So how do we answer this question in this case? In order for you to answer this question, in order for you to shipments to be accepted, your acceptance rates has to be 95%. Yeah, again, why we use acceptance rates has to be 95% is again remember the 5% that we always use. So that means that your rejection rate is only 5% in this case. So that is why we always use 5% since the beginning of the class. Remember when we do the statistically significantly, we use 5%. Or a lot of things that we use here is a 5% cutoff point here. So we will be talking about that in today's class. So since this rejection rate, 33.85, is definitely more than 5%. So that is the reason why that this is mostly being rejected. Okay. So this means the shipments are mostly rejected. Okay. So in order for you to answer accepted, then this percentage that you calculate here has to be less than 5% or less. Okay. So usually in your homework, you can figure out very easily by looking at your acceptance rate. If your acceptance rate is very high, how high is your acceptance rate? We want the acceptance rate to be as high as 95% or more. Okay. Then we will mostly accept it. But if you don't get 95%, you got 60, 50, 70, or even 80%, then you can tell that mostly we will reject these shipments. Okay? Or as what we did, we can calculate the probability of rejection rate here. And that's how you figure out this is higher than 5%. Okay. Any questions with this question number 4? Now, I just want to point out to you that there is quite a bit of homework due on this coming Wednesday here. I think around 5 or 6 homeworks. So I'm not kidding you here. So I would highly recommend you guys to please start working on your homework. Do not procrastinate. So spend some time on it this weekend, and then and then when we meet again next week, you got questions for me, we'll go over those questions. Okay. Right. Anyone have any questions in this chapter 5.2? Okay. If you do, please let me know. Don't be shy. Okay. So in chapter 5, everything we did here is what we call as a discrete probability, where everything we did here is countable, 0, 1, 2, 3, 4, 5. Like what we did here is number of aspirin. You got 0, 1, 2, 3, 4, 5. You cannot have half of aspirin. Same thing here. We're talking about number of pea in green pea in the pots. Again, your green pea in this case is either 0, 1, 2, 3, 4, 5. Okay. And then same thing here. How many students are using cell phones in the classroom? Again, there are only 0, 1, 2, 3, 4, 5 students. You can have decimal representation here. So what we did so far here is how many senators? Again, 0, 1, 2, 3, 4, 5 senators. We cannot use decimals here. So this is all discrete here. Okay. Then when you hit chapter 6 is a different story, because in chapter 6, when you do this chapter 6, majority of them is going to be what we call as a continuous case. So your variable in this case will be a continuous variable here. It will be like height, weight, IQ scores. Okay. So if you just look at the examples, I just go down and let you look at the examples. So you guys know that when you do your test, this is talking about voltage. Okay. And voltage can be written down in decimals. So that is the continuous case. So usually I put it down here. Can be decimal. Easy way here. So you find out that majority of chapter 6 work here. This is talking about the thermometer reading. So temperature in this case is all in decimals. Okay, you can tell that. And then the whole chapter 6, this is all about IQ scores. It can be decimals. Okay, this is talking about the height of men and women's, also can be decimals. So I will point out to you that majority of here we are doing is going to be continuous variable here, where decimals will be represented in this case. Okay, so let's go through this. So the most famous continuous probability distribution is called the standard normal distribution. So now we learned about the normal distribution before. Based on what we learned last time, a normal distribution is where you have low, high, low, or it's a bell shape, right? This is a normal distribution here. So so this is it's symmetrical, right? Right in the middle, you cut right in the middle, symmetrical. Symmetrical and bell shape, okay? And you do not need to worry about this equation. This is the equation that we use to draw this line, okay? Like remember last time you learned in your algebra class, y equals to mx plus b. The line is a straight horizontal line like this. So in order for you to draw a bell-shaped curve, the equation is not y equals mx plus b anymore. It's going to be this equation, okay? So in this chapter 6.1, we will talk another type. So one of them is called the uniform distribution. What is uniform distribution? This is also a continuous case here. As you remember that everything we learn here is continuous case. Uniform distribution is a rectangular, let me highlight things here. So it is a continuous, one of them is uniform, and this is where it is a rectangular shape. Okay, we talked about this distribution back in chapter 2. An example of a uniform distribution is like cruise control in the car, right? If you put your car in the cruise control, you measure the speed, it's going to be the same throughout the whole time, right? Except if you hit the brake or if you speed up, but if you don't, just same speed. So this is called a uniform distribution. Now, so this uniform distribution has what we call as the density curve. Okay, what is density curve? The density curve is the one that is the inside here. So the density curve in this case is a rectangular shape. This is called density curve. The density curve for a normal distribution is a bell shape. Okay, so this is called a density curve. So it goes from one end, so the shading area underneath it. Okay, So since we know that we are looking for probabilities, yes. So as you guys know that we are finding probabilities here. In order for us to find probability of a rectangular or uniform distribution, you can actually find the area of it. Okay. Now there are two ways for us to do this. If you remember the area of the rectangular formula, which is very easy, width times length. So if you find out what is the width and what is the length, you can find the area's formula in this. You can find the area in this case. And again, area is the same as the probability. However, you do not need to do this. Okay, so we will be using StatCrunch to find the probability. Okay, so you do not need to use the area formula. Again, when you use the homework, when you do your homework, they will use the formula to find the area. There are two requirements for a density curve. So last time we called the chapter 5 is called the probability distribution, right? So we don't have a graph on it. And if you want to draw the graph will look something like this. This is what happens when you do a discrete case. It's gonna be it's not gonna be a curve here. It's not gonna be like a bar graph. Okay, little lines on it. And this line is a probability. Okay. But once you do the continuous case, you will have a graph. And this time the graph will involve with a density curve. Okay. The one, what is density curve? The one that you shaded down, the green one. So those are called a density curve. And the first thing you need to know is the total area has to be equals to 1. Okay. That means that the total area for this curve has to be 1. The total area for the whole density curve of a normal distribution, this has to be, the total has to be 1. The reason why the whole density curve has to be 1 is because probability, because you cannot go above 1. And as you know, that area cannot be negative. Smallest area you can have is 0. Okay. So in this case, because since your total area has to be equal to 1, this is very important. Areas and probability is the same. Okay. So what it means here is that the areas and the probability is the same thing. Okay. So that means that if a question wants you to find the probability, you just find the area in this case. Okay. Now for the uniform, again, there are two ways to find the area here. One is using the formula. The other way is using the let me highlight this. Using StatCrunch. So I'll be using StatCrunch. So in this case, we will be using stat calculators uniform. Okay. So by tomorrow, by the end of tomorrow, I will show you all the StatCrunch calculators link, which one is which, so that when you guys do this, you know, oh, if you want to find this, you go here. You want to find this, you use these links. Okay. Where they will ask you to put in your minimum and the maximum. And then you only have 3. Last time, remember, we have 5. Exactly, more than, less than, at least, at most, we got 5 of them. So in this case, we only will have 3 types. Either you use greater than, which is this symbol, less than, which is this symbol, and in between. In between means in the middle. And then some of you will ask me, David, why, if you have greater than, you use greater than or equal to symbol, and when you have less than, you use less than or equal to symbol. Why we not using this symbol? Okay, remember last time when I say less than or greater, we use this symbol. But for this case, why for greater and less than we use the one with the equal to? The reason why that is the equal to is because the probability of equal to, of exactly, which is equal, for a continuous random variable is always 0. So what happened to? uh, there you go. For continuous random variable is always 0. The area of a line is 0. Okay. Now I will explain to you why the probability for this exactly, which is equal to, for a continuous random variable is always 0 is, now we know that probability and area is the same, right? So if I want you to find certain area, you have to shade the area here. Now, what happens when you have equal to? Equal to in this case is just a line. So if I say equal to, this is just a line. That's why when you see the continuous case of line, what is the area of this line? This area is actually 0. Okay, so that's the reason why that the area of a line is always 0, because you cannot find an area here. So that's why that when you have greater than is also the same thing as greater than or equals to. Okay, if you want to find less than, it's the same thing as less than or equal to. Only for continuous case, chapter 6. You cannot apply this in chapter 5, the one that we just did just now. Only for chapter 6, and the reason why is because the area here is always 0. Okay, and the mean is always provided in the question, and the max is always provided in the question. So in the question, that has to provide you mean and max. Okay, so let me show you where is it at, so you guys know where to go. So in StatCrunch, you go to Stat, Calculators. Now, last time we did binomial, and the 5.1 we did custom. This time we will do what we call as uniform, which is right here. Okay, and when you click on it, you will get a rectangular shape. Okay, and you will notice that in this rectangular shape, they will ask you for the lower and the upper, which is the minimum and the maximum. Okay, and then you only have 2 choices here, either less than or equal to or greater than or equal to. Okay, now if a question wants you to do the in between means right in the middle. So I just want to point out, if it's less than, the shading is on the left side. If it's a greater than, the shading is on the right side. Between means the shading in the middle. So where do you go for the between one? It is right in here. Okay, so if you click in the middle, in up here, that means you'll be in between. So in between means your shading is the middle. So if you go for the standard, you go either less than or greater than one side. Okay, depends on the question what they want to ask you. But if you click the between, it is right in the middle. So you have to put in 2 numbers here because you are doing in between of these 2 numbers. Okay, so this is called a uniform distribution. So it's very important to know this. Okay, I don't know why I cannot do that. Next is normal distribution. So we have what we call as a standard normal distribution. Now, what is a standard normal distribution? Okay, so a standard normal distribution is where it's a normal curve. Okay, where in a standard normal distribution, the mean is always 0, and the standard deviation is always 1. So this is the standard normal distribution. The mean is 0. The standard deviation is 1. Now, this is how we draw this picture for the normal distribution. You draw a bell-shaped curve. Do not need to be perfect symmetrical bell shape, just a bell-shaped curve. And 0 is in the mean, so that means right in the middle is 0. And if you put a number up front, up on top here, that is the standard deviation. And this is a very common way that statisticians do. So if you draw this picture and show it to a statistician, they understand that the middle part here is your mean. The number above it is your standard deviation. And moreover, this is not the sample. This is the population mean, mu, and the population standard deviation, sigma. So what we're doing here in this chapter 5 and 6 is geared towards population parameter, not doing a sample statistics. And then The total area under the density curve is 1. So what does that mean here is the whole area here is 1. Okay, the whole area has to be 1. Okay. Now, when you guys do the standard normal distribution here, make sure you have to be careful with these two things between the z-score and the area. Now, we talk about area in this case. Area is always the region under the curve, which is the same as probability. So the one that we shading here is the area. We call that as the probability. But what is the z-score? Z-score is the distance along the horizontal scales on the standard normal distribution. So where is z-score at? The z-score is right here. These are your z-score. Okay, these are your z-score. And as you know that if you go above on the right side, means the z-score is positive, means you're above the mean. If you go for the left side, it should be a negative because it should be below the mean in this case. Okay, so why I'm pointing this out to you very carefully here is because in your homework, either if I want you to find probability, then I will give you the z-score. If I want you to find the z-score, I will give you the area, the probability. So that means that you need to know where you need to figure out. Okay, so I will give you, that means there are two unknown variables here. One of the variables will be given in the question to find the other variables. Okay, so make sure you know which one is which. Okay, so I will tell you how do you find it. Okay. Next is the critical value. So what is the critical value? Critical value is a z-score that's separating between significantly low and significantly high. Okay. Now, we did this before last time. We always use the -2 and the +2 because for your z-score. So if your z-score is below -2 or equal to it, is significantly low, and high will be 2 or more. So this number is what we call as your critical value. This is called CV, short form it. So we will begin to use this to find this CV here. So when you guys do this to find the CV, you will use it to find a CV here. Your z-score is always gonna be denoted by z alpha. So that is your critical value. That means that your alpha here is always shading to the right. Okay, I'll draw you a picture in this case. So for the critical value in this case, it's gonna be always shading to the right. And this is your alpha. And this z-score is your z alpha. This is what we're looking for. Okay, so alpha is a number. This number can be 5%, 10%, 1%. So if it's 5%, then you put 5% in here and you would figure out what is z of 5%. That is your critical value you're finding here. How do you find this? How do you find all these z-scores and all these areas here? Is using StatCrunch. Okay, so this is very important class. So I'm going to highlight in a different color. If you want to find the probability, you use normal. If you find the z-score or the critical areas or critical values, you also use the same thing, normal. Now, this case, your mean and your standard deviation is 0 and 1. So make sure you guys do that. Okay. And then this is something I always tell my students here. Very important. So in this case, I will show it to you. They will give you PX in your StatCrunch. This is StatCrunch. Okay. Again, you either pick greater than or equal to, or you pick greater than or equal to, or you pick in between. And then you will see yourself having the first empty box, and then equal, and then you have the second empty box. Okay, so this is very important. So please pay attention. The first empty box is for z-score. Okay. And the second empty box is for probability. Okay. So if a question wants you to find the probability, means this fellow is blank, then you have to enter the z-score on this side. But if a question wants you to find a z-score, this will be blank, then this is where you put in your probability. Okay, so usually you make sure you know which one to use here. Again, I will show it to you later on here. How on the StatCrunch what is those. Okay, so when you do the probability, has no units, and your answer has to be between 0 and 1. Okay. When you find the z-score, usually it has units, and the answer is all real numbers. Means you can use any numbers. Your answer can be any numbers you want. So let me show you where is this finding normal distribution here. You go to stats, calculators, normal. Okay. So we used binomial last time, we used uniform, we used custom, now we do normal. And you get yourself a normal curve. Okay, so the mean stays at 0, the standard deviation stays at 1, and you have these two choices, either less than or greater than, depends on where you want to shade. If you want in between, then make sure you select the in between one. And then I just want you to hover the mouse over here. So, and don't move, just hover it over here, and then just leave it your mouse over by the first box here. Is written down as reference value. So that reference value that you see here is what we call as the z-score. And then if you move your mouse to the second box, you find out that that is the probability. So that means that's where you put your probability. And the number has to be between 0 and 1, if you see that. Okay. So if you misplace this, or if you put in the wrong position, you get yourself in the wrong answer. Okay, so this is very important in this case. Okay, I will go through some examples so you guys can see what is going on here. Okay, before I continue with a example here, I'm going to take attendance. So please, class, go to the chat room and do the attendance here. Anyone have any questions for me with this normal curve? By the way, if you guys do your online homework and do this standard normal distribution, they don't use StatCrunch, they use a table. I will show you what the table looks like. Normal table. It will look something like this. Okay, please do not use this table. This is the table you will get here. So when you guys do your homework or when you do help me to solve this, they will use this kind of tables. I will recommend you, please do not use this table. Use StatCrunch, okay? Otherwise, you will be having a difficult time understanding this. Use StatCrunch, okay? So please do not use the table. And if your tutor or whoever that helped you use this table, okay, or any table that looks weird like something like this, you can tell it's table. Please do not, these are the same thing. Do call the tutor stop, because otherwise you will even get more confused. Okay, so let's take a look at this example here. Let's read the example here, and I'll teach you how to pick up all the important keywords here. So Newport Power and Light Company provides electricity with a voltage level that are uniformly distributed between 123 and 125 volts. Just the first sentence. Okay. Now, these are the keywords that I want you guys to know. Okay. The first keywords, uniformly distributed. And the next two numbers here. So we kind of know that these two numbers is your minimum and your maximum. Now, and mostly in the question, they will say the word uniformly distributed. It means that we're going to use uniform distribution. Okay, so we're going to use uniform distribution. And as you know that uniform distribution needs two number, minimum, maximum. That's it. But if you read, sorry, if you read the question 3, the keyword we have in question 3 here is not uniformly, is normally distributed. You see the difference between these two, uniformly and normally. So yes, I will provide you this kind of keywords in the test. So make sure you read it carefully. If it's a uniform, make sure you use the uniform calculator. If it's a normal, use a normal calculator. So you can tell that majority of what we did so far is going to be a normal distributed. So same thing with 6.2, you find out that this is also normally distributed. So you find out that majority of them have this word, okay? Normally distributed or uniformly distributed. This is something that I want you guys to highlight or underline when you do the test, okay? Very important. So let's do the first question. We're going to draw this uniformly distributed. So the question wants us to draw this graph. So in order for you to draw the graph here, uniformly distributed is a rectangular shape. Okay, this is the first thing you need to know. And the minimum is 123, which is right over here. And the maximum is 125. So this is what the graph looks like. Okay. So, so this is how you draw your graph in this case. Question B is asking us to find the probability that is greater than 123.5. Now, in order for you to do this type of questions, you have to first draw me the graph. Second, you have to find the probability using StatCrunch, and then write down the last row or last sentence in StatCrunch. Remember last time when you do in StatCrunch, you have to write this whole thing up. Okay, so in StatCrunch, you have to write the whole, the last line up. Okay, so this usually in the test will give you 3 points. Okay, 1 point for the graph, 1 point to write the last row, and the last point is to figure out if your probability is correct. Okay. So how do we draw a picture in this case, or graph in this case? Again, don't need to be perfect. Just draw me a rectangle because it's a uniform distribution. It's a rectangular. The mean is 123. The max is 125. And the word greater means shading to the right. So make sure you know greater means you go to the right. 123.5. Now 123.5 is somewhere here. Okay. So somewhere here, again, just approximately. Okay. And the word greater means your shading is on the right. So if you draw me this picture correctly, you will earn a point. Okay. So that's what the graph looks like. Now you go to the StatCrunch. Okay. Now don't forget, this is a uniformly distributed. So yep, there you go. So you have to use a different calculator. So stats calculator uniform, that's a rectangle. The lower limit is your minimum, 123. Upper limit is 125. The word greater means you have to use this symbol. And the value you put in here is 123.5, which is given in the question. And you hit compute. And make sure that before you write, this is your answer, 0.75. Before you write your answer, please check, is this picture kind of the same as your picture? You say, yeah, these two pictures looks kind of the same, then you get it right. So what you do is write down the last sentence here. Px is greater than or equal to 123.5, close to parentheses, is 0.75. So again, where is your answer? This is your answer. 0.75 is your answer. Okay. But in your test, I want to see this. So this worth 3 points in your test. Okay. So make sure you guys draw the correct picture, write down the last sentence, and make sure the answer at the end is correct. 1 point each here. So so make sure you do this in your test. And then I got students. Oh, okay, I'm gonna start to do question B, number B2, less than 124.3. So what the students do is use back the same graph as the first question. Do not do that. If you do that, because each of this you have to draw its own graph. So another meaning you have to draw 3 graphs in this question B. But if you just try to be lazy and draw 1 graph for these 3 questions, I want to give you 1 point, so you lose the other 2 points. Okay, so make sure you draw the graph for each one of this, not just individual. Okay. For this case, again, the mean is still the same, 1, 2, 3. The max is still 1, 2, 5. But this time we want in question B2, you want to find less than 124.3. Less than means your shading is on the left side. 124.3, I think, is somewhere over here. So you're gonna cut this box into around 124.3, right in the right, a little bit on the right side here, and your shading is on the right side. So this is how you draw the picture here. And then how you use your stack crunch, same mean and same standard deviation, less than 124.3, and hit compute. So your answer is 0.65. So what you do is, again, copy down the very last sentence here, and that will give you your second point. And then if your answer is correct, you earn the third point. Anyone have any questions here? Next question, we're gonna find between 123.7 and 124.8. So in order for you to find this, again, we draw the picture. So 123 and 125. Okay. 1 is between, so that means it's shading in the middle. So 123.7 is somewhere here between this, and 124.8 is somewhere here. Okay. And between means your shading is in the middle here. Okay. So how do you do this in your stack crunch? You go click on the between. Still the same minimum and maximum, but this time you have to find between 123.7 and 124.8. So you have to enter 2 numbers when you do the in between one. So once you hit compute, your answer will be 0.55. So this is, you have to, don't forget, you have to write in the whole thing in here. So it will be P is 1.237.7 less than or equals to X, less than or equals to 124.8. And that answer in this case is 0.55. So this is your answer in this case. Anyone have any questions for me? Questions? Okay. So make sure you guys know this is for uniformly distributed. Question 2, you need to find what is Z10 or 0.10. Round your answer in 2 decimal place. What is this Z10 called? We call this as your critical value. Okay, so this is what we call as the Z alpha, the critical value. So so we're gonna draw a picture for this. Now, when you hear the word Z, it's no longer gonna be a rectangular. A Z in this case is gonna be a normal. Okay, so we do not gonna use this uniform calculator anymore. So we're gonna use the normal calculator. And this Z10, 0.0, 10%, is always on the shading on the right. So this is always 0.10. And you need to find what is the Z-score here. Okay, so this is what we call as a critical value, given us this 10%. And this 10% or 0.10 is always shading to the right. How did we do this? You had to use normal calculator. So you go under stat, calculators, and normal. Okay. The mean is 0, standard deviation is 1. Always that because it's a standard normal in this case. So that means if you want to draw this, this will be a 0, and this is 1. Okay. In order to find the z-score in this case, you have to find your shading here is on the right side. So make sure you change your inequality so that it will shade to the right side. And where do we put the 10, 0.10? Now, this is actually your area. Okay. And as you know that area is also the same as your probability. So please pay attention here. You will put that in not the first box, but you will put it in the second box because that second box is the probability. And you're going to put it as 0.10. So your critical value, your answer in this case is 1.28. Okay. So your z-score in this case will be 1.28. Okay. So you put it down as P, X greater than or equals to first box is empty. And then the second box is 0.10. This is where you put in your second box. And then when you hit compute, this is your answer. Does anyone have any questions to find this? And this is the easiest way for you to do this question. Otherwise, refer to the table. Okay, to refer to this table. You'll be crying if you use the table. I will guarantee that. Questions? Now, in question 3 and question 4, majority of this is normally distributed. So assuming that the thermometer are normally distributed with the mean of 0 and a standard deviation of 1. Okay. And the thermometer is randomly selected test. In each case, draw a sketch. So when I ask you to draw a sketch, means you to draw the picture here. And you have to find the probability, round your answer into 4 decimal place. Now, this question specifically asks for 4 decimal place, so you have to do that. But first thing first, you have to draw me the picture. So in question A, they want you to find what is the probability that is less than 1.23. So how do you draw your picture in this case? Draw me the normal curve. The mean is label it. The mean is 0. Standard is 1. Don't just simply draw it. Label it. And then in order for you to do part A here, 1.23 is somewhere here. This is your z-score, correct? And the word less than means your shading is on the left. So this is what question A picture looks like. Make sure you label them 0, 1, and make sure you shading correctly. How do you do this? How do you find this probability? You will use your stat cruncher in the normal calculator. 0 and 1, since we are using our shading is on the left, so it's less than. And where do we put the 1.23? Now, since this 1.23 is your z-score, so we will put this on the first one, call it as your reference value. Okay, so you're going to put it right here. And when you hit compute, this is your answer. And you have to round this into 4 decimal place. So again, I want you to write down the whole entire last line here. So Px is less than or equals to 1.23. This is 0.8907. And again, the last line that you see here, this is your answer. Now, what happens if you put 1.23 on the second box? Put the wrong box. You will probably get an error. The reason why you get an error is because probability can only be between 0 to 1. You give me 1.23, that means that you put it in the wrong box. Okay, so sometimes the stat crunch will tell you that, oh, it's an error because you put it in the wrong box. Okay, so then you could be switched around. Question B, 3B, you want to find that it's greater than 1.23. So how do you draw the picture here? Again, the mean is 0. The standard deviation is 1. 2.23 is your z-score. So it's going to be somewhere here. Above 0. And above have to be above 0 here. And then the word greater means your shading is on the right. Oh, by the way, I forgot to mention that when you do question A, make sure that the picture that you shown in StatCrunch match with the picture that is you drawn. If these two match, then majority your answer will be correct. If you have a different shading or it doesn't match at all, something is wrong, means your answer is wrong. Okay, just want to point out to you, make sure you match it. How do we do question B? Because it's a greater than, so we have to use greater than symbol here. Then you use 2.33. Again, this is your z-score in this case. Then you hit compute. So this is your answer, the one on the very end here. So your answer in this case will be px greater than or equals to 2.33 is 0.0099. Again, make sure you know how to round your answer in 4 decimal place. I think that is what your online homework wants you to do too, in 4 decimal place. So make sure you guys know how to round this in 4 decimal place. Anyone have any question for me? All right, for part C, in this part C, they want you to find that is between these two numbers. So, so how do you draw the picture? Again, the mean is 0. The standard deviation is always 1 based on this. Negative 2.87 between and negative 1.35. And the word between means your shading is right in the middle. Okay. How do we do this question in StatCrunch? You go to the between symbol. Make sure you click on the between symbol right here. Mean and 0, solution is 1. Is between negative 2.87 to negative 1.35. And this is your answer here. So you had to write down the last number here. P negative 2.87 is less than or equals to x is less than or equals to negative 1.35. This is 0.0865. 0.0865 in 4 decimal place because the 5 is big enough to round up. So this is your answer for question C. Anyone have any questions here? And I will point out that if you know how to do this kind of questions 3 and question 4 in 6.1, you should know how to do the same thing in 6.2 and also 6.4. So the entire chapter 6 is based on here. So if you know how to do this, then 6.3, the next 2 sections after that is the same. Okay. You will see the difference tomorrow when I go over in class. What is the difference here? But majority of them is going to be the same. Very similar. Next, now we use back in question 4, use back the same example 3 information, means it's normally distributed with a mean of 0 and central 1. Now you need to find P80. Now you see the question change immediately because when you look at question 3 ABC, they ask you to find the probability. And if you remember how you find the probability, we always leave the second box empty because that's the probability. But for this kind of questions, find P80, which is 80th percentile. Find IQR, the interquartile range. Find 2.5% that are too high and 2.5% that are too low. So this kind of questions means that you have to find the z-score. This is very important class. So this kind of questions means you have to find the z-score. Or in your StatCrunch, you have to find your reference value. So in this case, you have to put this on the number on the probability side. That means that the first box has to be empty. So make sure you guys know the difference between question 3 and question 4, because a lot of students get these two confused. Okay. So how do we do question number 3? Again, you need to draw the picture here. So what is 80th percentile, or P80 here? 80th percentile means your bottom 80% from the top 20%. Again, to draw this, your mean is 0, standard deviation is 1. So the bottom 80%. Now, bottom 80% means that this, if you shade, this is actually 50%. Okay, this is half. So bottom 80% is somewhere here. So this is the bottom 80%. That means the shading is always on the left side. Okay, so this is very important. So when you do the percentile, the shading is to the left. Okay, so very important, class. This is so important. And you need to find what is this P80s. Okay. How do we do this? Again, mean is 0, standard is 1. We have to change it to less than. You have to change this 80% into decimals, which in this case will be 0.80. And you're going to put this in the second box. Okay, so your answer will be, for the 80th percentile is 0.8416. And don't forget, in order for you to find this percentile, you need to have units. And the units in this case is degrees Celsius. Okay, we don't have any units for probability that you did in question 3, but in question 4 you do. Again, I'm going to put it down here in your StatCrunch, which you needed to put this in your test. This is how you put it in. And this is your answer. Questions, anyone? Questions? Now, in question B, they want you to find IQR. So if you remember what IQR is actually Q3 minus Q1. And Q3 is the same as the 75 percentile. And Q1 is the same as the 25 percentile. Okay, so in order for us to find Q3, I'll use a different shading here. Q3 in this case is 75%. Now, don't forget, last time this is 80th percentile. So this purple shading in this case, this is 75%. Okay, so this is your Q3. Okay, and then you have to find the 25 percentile. The one that I shade in green, this is 25 percentile, or in this case, Q1. So you need to find the purple one, and then you find the green one, and then you subtract them. So how do you find the purple one? Exactly the same as how you do in question A, but you don't use 0.8 here, you use 0.75. Okay, so what we do here is everything is the same. You just need to change this to 0.75, which is the third quartile, and that it came out to be 0.6745. Okay, so you change it to 0.75. And so this is your Q1, or Q3, sorry, that's your Q3. Next, you have to figure out what is your Q1, the green one. So what we do is, same thing, instead of using 0.75, you will change this point to 0.25. So what I do here is change this to 0.25. So you notice that this is exactly the same as the 0.7, the Q3, the 75 percentile, but the value is negative. So you find out that this value is negative, exactly the same. So they're kind of symmetrical. So, you know, they should be the same. So how do you find your IQR in this case? So IQR in this case will be taking Q3 minus Q1. Q3 in this case is 0.6745 minus your IQR, Q1, which is also the same, but it's negative 0.6745. Now, you know that in math, 2 negative will become a positive. So in other words, you just need to add it up. So take out the calculator and add 0.6745 plus 0.6745. Your answer will be 1.349. And don't forget the unit is degree Celsius. So this is how you find the IQR for question B. Okay. Now, I don't have room for question C, so I will put it way down here. Now, what is that meaning when I question asks for 2.5% of the thermometer rejected are reading too high, and another 2.5% thermometer is rejected because the reading is too low? Okay, so this is what it means here for question C. Okay, 2.5% too high means that on the high end, the shading is on the right. This is 2.5%. So this is called 2.5% too high. Okay. And then what is the meaning of the word 2.5% too low? I will put it in orange here. So for 2.5% too low is the other one. So that means it's on this side. This is 2.5%. Okay. So what we need to do, class, is we have to change the percentage into decimals. So this is where a lot of students make mistake here. So if you want, I recommend take out a calculator here. So this is actually 2.5 divided by 100. So this is actually 0.025. Just want to point out to you that if you put in the wrong zeros or wrong decimals, you get the wrong answer here. So how do we find this 2.5% too high? This is considered high in this case. You just need to use your StatCrunch, go for greater than because we are shading on the right, and you will put 0.025. So this is going to be around 1.96. So this answer in this case will be 1.96 degrees Celsius. So this is 2.5% too high. Okay, the one I highlight in green. In order for us to do 2.5% too low, again, I have to convert this into decimals, which is 0.025. And how do we do this in StatCrunch is you have to move this to the left and put the 0.025 in the second box. And you will notice that the answer is exactly the same as the high one. This is the low case, except negative. The reason why is because it's symmetric. Okay. So this will be 2.5% too low. So this is how you do question C here. And I know we go through quite a bit fast here. So, so this homework is going to be due on next week, Wednesday too. So start working your homework. Don't stop, especially this weekend here. And then I will bring up the last thing about this before we end today's class. Now, remember what you guys did in empirical rule. Okay, this is back in chapter 3 here. So if you did your homework, you should remember your empirical rule in this case. In the empirical rule that we did last time, you notice that the 95, the 68, 95, and 99.7%. This is the last one we're going to talk about here. So that can be done by StatCrunch. Okay, this is actually the same thing we just did. So remember this empirical rule, 68% fall within 1 standard deviation. So if you go for your normal calculator, you go for between, And if you go from -1 to 1, okay, this you will get close to 68%. So the correct figure should be 68.27%. But because we don't want to give you all the decimals, so we just round it to 68%. So the empirical rule that you did last time, 68, 95, 99.7, is actually come from the normal calculator here. And if you look for the second one, it says 95% falls between 2 standard deviation. And when you look at this, should be 95.45%, but we make it 95 to make it easier for you guys. And then for the 3 standard deviation, within 3 standard deviation, using empirical is 99.7%. And yes, this is actually will be 99.73%. So that is what where is this come from? Moreover, if you remember that we did the empirical rule here, we find out that 34% falls within 1 standard deviation. So if you go from between 0 to 1, this is called a 1 standard deviation, you should get very close to 34%. In this case, should be 34.13%. And then when you go for the second one, the green one is 13.5. So that means this is between the first and the second standard deviation. So you should get around 13.6%. And then so on, so on. If you go on to the third and the second and the third one, you should get around 2.35, should be 2.14. And then you go from 3 to infinity. Now, how do you go infinity in StatCrunch? Infinities, you just put bunch of 9s at back. Okay, that's the infinity symbol. You should get to be very close to 0.15, should be 0.13%. So now my question in the test is, which one should you use when you do this kind of question? Can you use a normal calculator, or are we using all these percentages that I teach you in chapter 3? My answer to you is you have to use these percentages. You cannot use the StatCrunch in this case, because in your test, I will specifically ask you to use the empirical rule in this case. So once I call you to use the empirical rule, then you have to stick with this, this picture, not using your StatCrunch. If you use your StatCrunch and figure out these percentages, you will get it wrong. Okay. I'm going to stop here and I will talk about this again on tomorrow's class so you guys know about